Hey, in this one I wanted to show you how lambdas are implemented because yeah, it's something that surprised me a lot. Like you have those function, you can have them on the stack, and you can also capture stuff from them. I've done videos in the past about lambdas if you want to watch those before. Uh, and yeah, how does that all work? What does the compiler does under the hood to help you out? And yeah, it's quite interesting actually. So I will show it to you. So here I have the simplest possible lambda, which just yeah, you can call it. The body of it is just a print, and as you can see, it prints. And what the compiler does under the hood is something like this. Like let's say bar lambda. So it creates a class for you, and it has an operator parenthesis. So this is the operator which is called when you call your instance of a class. And in this case, it takes 0 arguments. It's const, and let's have the same hello from bar kind of thing. And this is basically what it does. And oh no, also it does for you the instantiation of the type. So here I have an instance of bar, and if I call bar like so, you will see that it works exactly like my foo function. And so all of this is done for you by the compiler. This is what this syntax sugar boils down to, just creating a class, instantiating it, and having an operator overload. So yeah, that's mainly it. There is also an interesting things about capture. So if I have a int a, let's say 42, and I capture this a, and then I print it, and here let's do the same thing as well, like this. So we should have an a here, of course, now we don't. And so it will basically create for you an instance, a class attribute, a class member, which is called a, which will be your capture, and it will also create a constructor, which is a bar lambda in my case. Let's say I underscore, and then initiate a with the thing, and then here I have to call it with a, and this is how it captures stuff from the scope. So here you can see there's both captures. If I capture it via reference, it will have our member, but via reference, and so well, this is always a reference, but now a is a reference. Yeah, there's other cool stuff to show, but yeah, that's basically it. I think for the rest of this video, I will switch to CPP Insight, which is a really nice website that does basically what I was doing from the beginning, but it allows me to not type all the boilerplate stuff. So if I do f, just like I had before with my cd print ln hello from f, like so, and I click run. Oh yeah, I need to use CPP 23. So if I compile this, okay, this is a bit too tiny. Let me resize this. So yeah, you can see it's a bit more complicated, but basically it's kind of the same thing. Let me call f as well so that we can orientate ourselves. And so yeah, here you can see that they created an instance of this type underscore lambda something something f, which used the default constructor, and then they called the operator, the call operator on it. I don't know how this is called. But yeah, you can see here, for example, this is the void operator, which has the println inside of it. And if I do like my capture like before, so I capture a, and let's print a here as well, we will see that if it compiles, that it also created a constructor with a. It has now a member called a. If I capture it by by reference instead, you will see that this member here will change to a reference. Yes, like so. There is also like the, let's say I have multiple variable in scope, like 43, and then in C 45, and so on and so on. And there is this thing where if you just place equal, it will try to capture everything that you use as from the outer scope. And so here the compiler will see that I'm using A in my lambda, and so it will basically capture only A as a copy. So this will not change. But let's say that now I also use B in my lambda, like so. Now it will also capture B. We will see. See, there is a call that it captured A and B. And of course, if you capture everything everything that you use by reference, it will also just add the references here. This helped me a lot because I thought like that let's say the default capture thing was literally capturing all the outer scope, but turns out, yeah, it was kind of obvious in hindsight, but that the compiler is smart enough to only capture the stuff that you need. You will notice as well that the operator is by default const. So if I try to do something like A++ here, it will not compile, like so. Exited with code 0. Actually it did. Huh. Oh! Wait. Okay, I think I understand now. It's basically because I capture it by reference, and so like if I do A++, I'm not theoretically modifying a member, I'm modifying the thing, let's say pointed, referenced, which I didn't knew. But if I capture it by copy instead, this time I'm actually modifying a member of the lambda, and the compilation fails. You can fix that by change that by adding mutable here, which will make your operator thing which will allow your operator function here to modify its members. Other stuff that I wanted to point out is that you can, if we go back to not incrementing it, you can specify the type. So you see that here it has deducted the type for us as void, but let's say if I return 42, it will basically deduce the type as an int, or it should. Yes, it did. But you can change this by with the arrow thing, like yeah, the arrow. I don't know the name. There is so much weird names in C++, but this can be like a long if I want it to be, which is useful in some situation where the compiler cannot infer the type. So here you see it's a long. Also, yeah, I didn't show arguments, but obviously arguments work. Like if I have an argument x, it will just have an argument. Oof, what is this? The editor on this is not great, but okay. So yeah, here you will see that the operator parenthesis, yeah, because I forgot to call it with some value. The operator parenthesis has now an argument x, as you would expect here. There is a, and yeah, apparently, like, because I've seen this concept of like anonymous functions in a lot of other languages, like JavaScript have them, Python has them, Rust has them, and so on. And like, if you only take the compiled language, I know like Rust and C, and basically this is not at all what function pointers are in C. Like function pointers are literally just the address of a function. This has like like members, and it needs to be allocated and put somewhere. But so yeah, there is a clear difference between like function pointers and what closures are. And so lambdas in C++ are more like the closure kind of thing. And yeah, yeah, I think that's about all I have to say for this video. Just yeah, just kind of cool to know that this is how lambdas or closure work under the hood. Yeah, I was mentioning all the closure thing to know, like, this is probably how, very similar to how other language implement them, so it's kind of just good to know in general as well. Um, so yeah, that's all I've got for today, and hope you learned something as usual, and see you in the next one.